Welcome, welcome, welcome. My name is Professor Wield. You may see my name as Paul Wield. You may see it as Jeff Wield. My full name is Paul Jeffrey Wield, and I go by my middle name, but you can call me Professor Wield. I'm glad you're here. I'm glad that you're interested in this mechatronics class, and I hope this video will give you some insight into how best to succeed in this lab course. And that bell could mean only one thing, that it's time to start a mechatronics lab class. I am recording my normal introduction to the course, and this introduction is good for both ME 230 and ME 330. If you're tuning in now, perhaps you liked it so much in person that you wanted to see it again, or perhaps you did not have the opportunity to see it for the first time. You'd like to learn a little bit more about this course.
Forgot my tools again. Such a show off.
So I wanted to share that video with you to give you some expectation that maybe you won't be able to program that robot, but you should at least be able to do a forward somersault with a twist by the time you get done. I'd like to take this opportunity to go over with you this agenda. This will take me, has taken me about an hour and a half. We'll see if I can do some creative editing on this video to get it a little bit shorter, but still give you the full perspective of what I was able to share last week in our classes. My background is predominantly with 35 years of industry experience. I graduated with a master's degree from San Diego State quite a while ago, but I feel like I've come on a full tour here of being launched into my career from San Diego State Engineering Department and now coming back to it to share what happened during those last 35 years. Well, I can't quite share all of that with you, but I'm happy to be with you and to learn your perspective on how things are going. My purpose is to make you successful in your careers, and that's why I'm here. Another reason that I'm here is I enjoy meeting all of you, understanding where you're coming from, and what your unique perspectives are. Diversity is important to me. It's important to San Diego State University. We will have students in our classes that are various gender identifications, various orientations, different faiths. We have people from the military, people of different nationalities and citizenship status, and transfer students. I especially do a shout out to transfer students, being one that myself. Also recognize some students are working full-time, part-time, maybe double time with 2 jobs, supporting a family, trying to get a degree. I admire your activities and I appreciate your priorities in that you may have to make some trade-offs here in order to be able to support all the things that you're trying to get done. My purpose is to make sure that you're achieving the goals that you've set for yourself. I want you to know, whoever you are, wherever you are on life's journey, you are welcome here. Many of you may have or should have already opened up the Canvas for this course. This is a separate Canvas from the lecture course. The courses are it's the same course, but we've separated into two different Canvas sections because of the different content that's in here. The schedule that we have here for tentative schedule for ME 230. If you're in ME 230, we have these 6 labs, but we have a couple of makeup sessions, so that may be necessary if you feel that you need to take a little extra time on those labs. Similarly with ME 330, our basic schedule is as you see it. We have 6 labs, a little bit more in the area of control systems. I'd like to share with you what I share with each of my in each of my classes, which is the key success factors for life, engineering, and quality. Let's take a look. Key success factor to life, at least in my opinion, is to show up. When you can show up and be present, meet people eyeball to eyeball, you will find that things open up for you. Networking, people are reminded of your interest in your capabilities, in your enthusiasm. So not only show up in class, but show up on the job, show up to company events, and be present. Key success factor for engineering is to visualize. Visualize in your mind what's going on, and think about things down to the molecular level. Think about things, what's happening temperature-wise, what's happening control system-wise, reaction-wise, in the mechanics, in the electronics. Which way is the current flowing? How much current is flowing through different components of your circuits? What does it take to activate a transistor and an op amp? Visualize. Key to success in everything you do in engineering. The key to success in quality is a little more unintuitive, perhaps, and that is value failure. That failure that you may find, a circuit that doesn't work, a mechanism that's not doing what it's supposed to do. Perhaps you're testing a prototype product and it's failed a particular test. Value that failure. Be happy about that failure. You have just uncovered buried treasure, information that is key to the quality of the products and the work that you're doing. In this class, you may find failure, not as far as the grade for the course, but potentially failure as you build a circuit and it doesn't work. You build a servo and it doesn't turn, or it turns backwards. Those types of failures are things that you should value because of the learning experience you're going to get. If you put everything together and it works the first time, you're not going to learn as much as the student next to you that finds something that doesn't work and figures out why, solves it, and troubleshoots it. In this course, we've got a number of different resources that I need you to take a look at. By now, you should have purchased the components kit. That's a $77 purchase for those in ME 230. That same kit, if you take good care of it, will be used in ME 330 when you take your follow-on course. In ME 330, you'll purchase this kit, and hopefully those components, as well as the microcontroller that's in there, will be useful for you possibly useful in your senior projects. I'm going to provide you with the National Instruments Elvis 2 Plus workstation, motor drivers, spare parts if you need them. If you blow out all your transistors in your kit, I'm here for you. I can provide you with some spares. We'll be using MATLAB, and I think you should be familiar with MATLAB. Be using Multisim Live in ME 230, Multisim Pro in ME 330. A little bit of Multisim Pro in ME 230, and it's possible in our first lab in ME 330 we'll use Multisim Live. If you're familiar with those, if you're familiar with Multisim Live, Multisim Pro has all the same features. It's just that it does it in a much more sophisticated industry standard type software and I want to make sure you're able to access that. We'll use the Arduino integrated development environment, just the software that we use to program Arduinos, which is the microcontroller that we're going to be using, and we'll be using some cloud software with CatMe. More about that in a minute. This is the list of components that'll be in your kit. So when you get your kit, open it up. Make sure you got all those components in there, and hopefully you can be familiar with them. Get familiar with them. If you have some resistors and LEDs, potentiometers, we'll be using each of these, and bring your kit with you to each lab, or if you're looking ahead, you can just bring the components that you'll need for each lab. Each student will be working on their own individual circuits, but we will be working in groups of 4 to be able to support each other, and also to be able to write a group lab report. Our group structure is maybe a little bit different than what you're used to. There is an Abbott accreditation requirement that students learn and demonstrate teamwork, collaboration, as well as analysis and drawing good engineering conclusions. So you'll see the direction that I'm taking for this lab is to measure and enhance your capability to do those. If we compare labs that are typically structured as compared to groups structure that you would see in the industry, you might find that there are some differences, as was investigated in these reports. Job roles are well defined. Individuals are held accountable for their contribution. That's what we see in the industry. That's not typically what we see in an academic lab group. However, in this lab, you will have assigned job roles and be held accountable for your teamwork and contribution. Another thing we see in the industry is that technical problems that you face on the job are different than those that you encountered in school. Work problems are typically ambiguous. They're more complex. They lack complete data. And in this lab, you should have the expectation that you will have the responsibility to resolve ambiguities, troubleshoot problems, including errors that may be in the lab instructions or defective parts. I may hand you defective parts. You may have workmanship errors. You may see code errors, either in the code that I give you or the code that you generate. In every situation, those are going to be your responsibility to find and resolve. A little bit more about that in a minute. Our group structure, we can expect in groups that when you form a group, people tend to be pretty polite to each other. They're strangers. They don't know exactly what to expect. As the group forms and you start working together, everybody's got a different expectation, a different point of view, and as those start to come out, we can see a storming stage of group development. Typically, that will get resolved into norming. We understand how to work with each other. We understand that there are differences, and we've figured out how to make things work. And then you get to a performing stage of group development where you start to recognize the strengths of people in your group that you don't have. The work starts gravitating towards those strengths, and as everybody works towards their own strengths and combines it, the outcome of the whole group is greater than the individual sum of the parts. Some people, some groups, and it happens every semester, several groups may get stuck in that storming stage of group development and need a little bit of help to get out of it. This is not your fault. This is typical. This is what happens when we bring people together. People have different personalities, different ideas. Sometimes it works well, and sometimes it needs a little help. When it needs a little help, I would like you to point that out to me. I would typically do an in-person meeting with everyone in the group if I get permission from everyone in the group to do that, and I'll create and facilitate a safe space, no judgment, and we'll talk through what some of the issues are, what some of the conflicts are. We can go from dysfunction to a high-performing group. I did have one group in the past, totally dysfunctional. We had an hour and a half talk. Right after that talk, they went to the norming section, the norming stage of development. Soon after that, they went to the performing stage of group development. In fact, they went to the highest performing stage, the highest performing group of all the groups out there. So that's my expectation, that you will flag for me when you need help. Know that this is typical, both in academic and in the industry, and I want you to learn. If you're lucky enough to be in that type of a group, you will be able to learn some of the techniques of being able to get through it. So take advantage of that if you're in that situation. Groups will be selected by CATME. CATME is some software that came out of Purdue University. They've done a lot of work in this area of how to structure academic groups and make them successful. So when you get that email, I will submit your email to CATME. You'll be on a class list in that software, and I'll trigger a survey to be done. When you get that email, go through and take the survey. It'll ask you some background questions. It'll also ask you what your schedule is, and then CATME will tell me who the groups, which people should be in which groups. I am not taking preferences. You may have people that you are used to working with, people that you know you can be successful with, or people you just like working with. Maybe they're your roommates. In this class, I want you to learn how to work with somebody you don't know and be able to go through those stages of group teamwork and development. Or not taking this survey in time will result in a reduction of points. So it's very easy to do. Make sure you get that done on time once it's out there. CATME is not connected to Canvas, so due dates on CATME will not be reflected in Canvas. You'll need to keep track of that, which I'm sure you can do. So there is one exception to student preferences, and I wouldn't call it a preference, but if you know that there is someone in this class who you absolutely cannot work with, I want you to email me before these groups are formed, not after, and I'll take that into consideration. This is not somebody you prefer not to work with. This is somebody you absolutely cannot work with, to the point where if you were in a group with this person, you would feel compelled to drop the class. Something that's that important to you. And you may have your own reasons. I don't necessarily need the personal details. And anything you do tell me at any time will always be kept confidential. Each person in each group, 4 people in a group, will be assigned a role. This role will change with each lab so that everybody will have a chance to fulfill every one of these roles. And then in the last lab, you and your group can select who's the best person for these particular roles. But I want you to practice and exercise doing work within each of these roles. And then I want each person in the group to realize that you have someone with an accountability in each of these areas. So you'll have that role for a particular lab. The labs last 1 week, 2 weeks, maybe 3 weeks, and then we'll switch roles. Grade expectations. Class average is going to be a B. So this is not the type of lab class where if you just show up and do the work, you get an A. This is the type of class where if you show up, do the work, and do it kind of in an average way, you'll get a B, and maybe that's not bad or meets your goal. There are 6 group lab reports. That's worth 50% of your lab grade, and the other 50% of your lab grade will be due to individual teamwork and contribution. This course is a 1/3 or maybe 35% of your overall course grade, and that overall course grade is controlled by your lecture professor, and I'll feed to that professor the outcome of your assessment in these labs. I mentioned that there is an expectation here for you to troubleshoot issues, and I want to emphasize that. You are engineers. Engineers are problem solvers. When you run across a problem, I want you to take a close look at it and figure out how to diagnose it, how to troubleshoot it, how to fix it. I do get this comment every semester from a number of different groups. I double checked and did everything right, but it still doesn't work. So if you've said that, then this infers you've given up. It's not your problem because you double checked it. You did everything right. What more could be expected of you? But if it still doesn't work, how are you going to fix it? If you come up to myself or the lab assistant and with that phrase, I double checked and did everything right, but it still doesn't work, That's okay. My next question to you will be, so what is your next step? What are you going to do? Creativity is one of your most important tools. Got to get creative and figure out what are you going to do next. This is how it works in the industry. Now, that doesn't mean you're on your own. Use every available resource. And that includes myself, it includes the lab assistant, it includes your teammates, it includes other groups, anyone you can find. I'm okay if you say, hey, we're troubleshooting this particular circuit and it doesn't work. Do you see anything obvious here? Or do you have any tips for what we should be looking at? Have you seen anything like this before? I might have some tips for you. I might say, you know what? You didn't plug your USB cable into the Arduino. That's why the code wasn't uploading. In some cases, I may see something and say, maybe you ought to double check whether your power supplies are working. But it is your responsibility. I also want to point out absences. Not everybody can attend every lab session. And especially if you have a health concern, I do want you to isolate, prevent others from possibly getting sick from something that is contagious. If you're isolating yourself, but you feel kind of okay, your group may allow you to just Zoom into that lab session where maybe from your isolation, you're writing the code for the Arduino and sending it to them, or you're working through the simulations and sharing that with them through screen shares. There's a number of ways you could still participate. If you are not feeling up to doing that either, it's like I just got to rest. I can't even think straight. There are makeup opportunities. Makeup opportunities revolve around my other sections, which you're welcome to come to. They're a little bit full, and I may or may not have room, or may not have the equipment that you need available. You can always feel free to drop in. Don't use these as a flexible time. You want to come to your assigned lab session, but if you run out of time for a lab, or you legitimately couldn't make it to a lab session, there is a way to make it up. It is expected that all your work, all the lab work will be done in order to get full credit. More on that later. Lab reports, which are half of your grade. There's a lab report template and guide that's out there. I'm going to go over some of the details that I expect to see in the lab reports. Lab reports are formal and kind of like research papers, and I think you're probably used to that. Each group will submit one lab report, and each team member's name should be next to the section that they are responsible for, the ones that they worked on. Because I look through those lab reports to see as a component of individual teamwork and contribution. If your work in a lab report is maybe doesn't have the quality or quantity of someone else, that could affect your teamwork score. It also may affect the overall lab report score. Everyone in the group will get the same score for their lab report, but the individual contributor scores can be a little different. Lab reports are due midnight before the start of the next lab. And that's done so that you're not working on the lab report during the lecture time. You've got it done midnight before, and you're ready to fully concentrate on the next lab and the next lecture. If it's a little bit late, let's say instead of getting it in at midnight, you got it in at 12:01 a.m. It's 0.42% reduction. That's not much. 0.42% per hour. The reason I do that is to be able to achieve a 10% per day reduction, but I don't want 10% off if it's a minute late. Submit it early. There are no excuses if it's late, if it's a minute late, if it's the next day late. If you tell me the next day that your internet failed, your computer crashed, Canvas crashed, my answer would be, what was your backup plan? Did that happen to your teammates as well? Did their internet crash? It doesn't matter that you might have been assigned to this task. Each of your teammates needs to verify that it was done. I've got 4 people in the group, and you should all be checking on each other. Here's some writing tip. I just read the word utilize too much. That's a 3-syllable word. We want to be efficient here. Why not use instead of utilize? Don't try to sound flowery and technical and throw in adjectives. Just plain English. Your own plain English is what I'm looking for. As I mentioned, student authors' names must be identified next to their responsible sections. The responsible sections include categories of experimentation and analyze and interpret. When you're discussing your experimentation, don't copy and paste the instructions from the lab manual. That's more of a cookbook, step by step. That's not what I want to see under experimentation. I want a higher level look at what did you do for the experiment. Where did you get the power supply from? Is it from a 9-volt battery? Is it from Elvis power supply? Tell me in your own words, at a higher level, how did you conduct the experiment? And especially when you did everything right and it still doesn't work, what did you do? What happened, and how did that troubleshooting go? I want to know what problem you came across and how you fixed it. Under analyze and interpret, there's an expectation that you're learning and demonstrating your capability to be able to collect data, interpret it through analysis, and draw good engineering conclusions. And as you're demonstrating that capability, I also want you to think beyond the lab. So what did you discover, and how could that apply in other situations outside the lab? For example, the torque fell short of the simulation by 10%. This can be attributed to contact resistances and part variances. The implications of this difference could be a product that is under-designed for the application. Mitigation might include using a simulation that can account for this difference or adding design margin. It's thinking beyond the lab. That's thinking, how would the information that I learned apply in the real world? Take notes during your lab. Any values you measure should be recorded. You should basically start writing the lab report as you're doing the lab. It'll make it a whole lot easier, because when you're writing, use third person. Don't use the pronouns I or we. If you do start writing in I or we, points will be deducted. Past tense should be used generally, and make sure all discussions are concise. For example, don't write, ironically, I found the evasive problem in our complex experimental setup to be the installation of the wrong resistor value, and I immediately replaced it with the correct value. How about just writing the resistor value was determined to be the cause of the problem and it was replaced with the correct value? There are no I's or we's in that, nor is there an excessive amount of adjectives. This is an experiment. We're not trying to write a novel. Don't use the flowery language that distracts from the experimental analysis. This flowery language can come from AI tools. If you were to ask an AI to write the report for you, you might get a paragraph that looks like the following, and I'll read it to you. The section commences with a comprehensive explanation of the basic set of procedures, aiming to establish a comprehensive comprehension among all participants regarding the laboratory setting and the available equipment. Subsequently, the theoretical foundation required for understanding the operational characteristics of servo systems and closed-loop setups is presented. The establishment of a theoretical foundation is of utmost importance in order to effectively analyze and evaluate the data and observations presented in the following sections. Upon completion of this module, students will possess the necessary skills and knowledge to initiate practical experimentation, thereby establishing the foundation for a thorough examination of closed-loop servo control systems. Now, I'm not sure what you thought of that. You may have tuned it out as I was talking, because that's what I would do if I started reading that. I would tune it out, and then I'd hand you your lab report back and say, you know what? Take a week or so and rewrite this in your own words and make it specific for this lab and make it meaningful. And by the way, when you take an extra week to do that, you automatically lose 50%. So I may not even look at the rest of the lab report once I see a paragraph that looks like this. I don't see really anything in that paragraph that would be useful or relevant to put in a lab report. Formatting captions for figures or below the figure, captions for tables or above the table, captions for equations or to the left of the equations. Remember to take a lot of pictures during the lab. You can always throw them away. Do not leave captions hanging on a separate page, and similarly, don't split data tables between two different pages. This can be pretty common, because what you're going to do is each of you will probably say, I'm going to write this section. Somebody else will compile it. Let's put it together. Okay, we got it all compiled. Yeah, but nobody looked at what does the end result look like. And if those tables went in, somebody pasted some information in the front, that table got pushed over, so half of it's on one page, half of it's on the other. You're going to lose quite a few points for that. So somebody should look at this when it's all done. Every person should read it through, make corrections, make sure that this shows your best work. And it's okay to have 3/4 of a page blank, because the next thing you want to show is a table that won't fit in that space. Just put it on the next page. Don't use your camera to take photos of the computer screen. Maybe that seems easy. You just pull it out, take a picture, and then I've got that. I put that in a report. You lose quite a few points for doing that. Use screen capture snippets while you're experimenting. Collect the data, and so you have it in a good format to include in a report. Last point, write your report from the viewpoint of a researcher that is investigating a topic. Don't write it from the viewpoint of a student who is learning a topic. The AI paragraph where it says, upon completion of this module, students possess the necessary skills and knowledge. I don't want you to write it from that viewpoint. I want you to write it as if you were writing something for work, not for an academic learning experience. So for example, don't write, "This lab provided students with the knowledge of how to tune a PID controller." Write something more like, "This lab provided the tuning characteristics for the positional server under test." You were asked uh, to, to characterize a particular system, perhaps even write a control system to operate it. Don't tell me that was a good learning experience. Tell me what the results were. What is the control system that worked best? What did you do to find that control system, to characterize it? The lab instructions are there to help and guide you to be able to do the learning, and I expect that you will, but write the lab report from the standpoint of something that you would hand your boss. Individual teamwork and contribution scoring that you'll have for that comes from a number of different sources. One of them is the peer evaluation survey, which comes at the end of each lab. It will be due midnight the day after your lab report's due. You will have an opportunity to evaluate the peers on your team, your teammates. You'll do that on a 1 to 5 scale in these 5 categories: contributing to the team's work, interacting with teammates, keeping the team on track, expecting quality, and having related knowledge, skills, and abilities. It's maybe intuitive what that 1 to 5 scale would be. I have included this rubric that comes from CATME. If you say, "I just want to calibrate," what do you mean by if I give somebody a number 1 on keeping the team on track? Well, this is kind of what that means. The way the software works, though, it will automatically look at how does each person of the team rate each other, and then sort of calibrate for you if there's any differences. If you're somebody that likes to give people 4s and 5s, another person on the team likes to give people 1s and 2s, CAPME will figure that out and and compile an overall score for you. Now, I suggest you do not try to game this system. If everybody in the group gave each other 5s for every category, CAPME would say you're all pretty average. Don't try to game the system. Put in place 3 being fairly average, 5 being far exceeding expectations, 1 being there's a problem here, and just be honest, and that will be the best that you can do for your teammates and for yourself overall. Another thing you can do is make sure you do the survey. If you don't do the survey, as you can see in this rater number 4, you're going to get a 10% loss in teamwork points because you didn't take the time to evaluate your teammates, as would be expected in the industry, to provide some feedback and evaluation of the performance of those folks that you're working with. Also in CATME, when you're doing this, it should be only take a few minutes, actually. They tell me that this is very easy the way it's set up. You're just clicking boxes. If you like, though, you can also add in some comments, and I have some examples of comments to the instructor. These are real comments with names changed to protect the students who actually made the comments. Everything that you do in here is held confidential, and your rating of your teammates will be merged with other ratings so that no individual will know exactly why their teamwork and collaboration skills might have been considered uh, high or low. Teamwork, collaboration, and contribution. You can easily also uh, share your joys and concerns with me. It's very easy for me to read all the comments that come in. Feel free to do that. Some people write comments like, hey, this is a great lab. I learned a lot. Some people say, this is a great group of people that I worked with. Some people say, I got to tell you, I rated everybody kind of high, but this one person really didn't do any work. And I want you to know that. Or we've got kind of a problem here. I don't know how to get along with these people, and they don't know how to get along with me. I might need some help. Uh, so flag any issues you want. Tell me your joys and concerns, and know that I will take those into consideration. That teamwork and contribution comes from three different sources: peer evaluation, my own observations, and if we have a lab assistant, the lab assistant's observations. Um, it also comes from the grader's observation of, hey, this person really did a lot on this particular section of the lab report. Should be recognized for that. Um, so those three things would be combined to give you a teamwork and collaboration score. The lab report score, it's going to be the same for each person in the group. So we're just going to take those points, it's 50 points for each, we're going to add them together. So if you have 41 for your group lab report, 43 for your teamwork and contribution, we'd add those together and you would get 84 points, 84% for the lab. If you did every task that was required in the lab. If you didn't, we got to reduce that score. So for example, if you're down here and you've only completed 2 out of the 6 tasks for the lab, sufficient enough to write up a section on the areas that you did, you were present for and did get checked off for the task, but not for these other sections. Maybe you only did 66.7%, 2/3 of the requirements for that lab. You're going to get 2/3 the grade you would have gotten otherwise. Each task in the lab will get checked off by either myself or the lab assistant. So as you finish a particular task, and this will be highlighted for you for each lab, you'll raise your hand, and when the entire team is ready to get checked off, and then we'll come over and say, well, show us what you did. Yes, we have a simulation. We have a physical circuits. All 4 of our teammates are finished with this task. Nobody's moving ahead until we get this verified and checked off. You may get asked a few questions like, so what does this circuit do? What would happen if we changed the resistor value? What do you, if you look at the graph, what would you estimate the time constant to be? And that's part of the checkoff as well. And if you don't know the answers to those, which is fine, I might just say, well, take 5 minutes and do some Google search, look in the slides, check your lecture notes, and just call me when you're ready. Again, come back and check you off. So it's an opportunity. Think about what you've done, and we can have a nice discussion. So we've talked through quite a bit. There is a course introduction quiz. This is on Canvas. It has a due date. You get 6 points towards your first teamwork contribution scores. These are the questions. As with this quiz and the pre-lab quizzes, which will be there for each lab that you do, take it as many times you want. So when you go through and say, yeah, I got that answer wrong. Okay, look up what the answer should be and take it again. There's no reason you shouldn't get a perfect score on every one of these pre-lab quizzes. So we have an introduction quiz based on this presentation of the course, the lab course. There is a pre-lab number 1 quiz. Same rules apply. The other thing I want you to do is take a look at safety training and acknowledgement survey. This should be a 1 question quiz. Maybe you got to type your name in or something. You review the video and then answer the question, did you review the video? So you should get full credit for that. And so get that done before the due date as well. We don't really have hazardous materials in this lab. We've just got some power supplies or 5 volts, 15 volts, 9 volts. This is not really a safety concern. We don't have any chemicals. What we do have is if you connect up your components in a way that is incorrect, you could overheat them. And if you go to pull out an overheated component because you think it might be bad and you got to put in a new one, you could get a minor burn to your fingers. So I do have a recommendation for that. If you feel that one of those components is overheated and it needs to be removed, just turn to your lab mate and say, would you mind taking this out for me? Think about that. So I have some supplemental material that's in our slide sets. Includes some of the schematics for the labs that we'll be doing. It also includes some more information, and that's why it's so important that you consider this class as not just a means to conduct an experiment that reinforces a lecture, but that you are learning teamwork and collaboration, individual contribution. You're learning how to work with others even better than perhaps you had in the past. Learning techniques to overcome dysfunction. You're also learning an ability to develop and conduct experimentation, analyze and interpret data, and use engineering judgment to draw conclusions. This is not a cookbook class. Can you follow these steps and get a picture that looks like my picture? I want you to use this class to say, hey, we've got an objective here. We've got to do some experimentation. We've got to collect some data, see what that data tells us, and then draw some conclusions from it. What are the implications outside of the class? Perhaps for other products, for other uses. What can we say about that? So I appreciate you being here. Thanks for your support. And if you need anything, let me know. I will see you in class.